Okay, hi. Seems like a bit of a delay or something. Okay, well, only a little more to go. So you see, we start this video with the R already going here, and I guess it doesn't matter. I could even just screen share, huh? So I just loaded in this table, and okay, so what are we doing? Just want to show you how to fit some basic, very basic, simple uh, single predictor nonlinear uh, models using the NLS command, and how to graph, how to plot the fits on top of the scatter plots and maybe adjust. So that's the whole goal of this. I try not to um, make it too long by spacing out and thinking about stuff. Okay, so I will, so let's just start. So I took something that I created this artificially, and it's got a form that's exponential. Okay, it's not a perfect exponential. I didn't want to make it perfect, so I put some noise in it, and I got more or less an exponential one. When I put it in the file, though, I put the response of the second column by accident and the predictor in the first column. So what I really want is something like, if I put, maybe let's try to do it like this, like if I go, yeah, let's make it bigger, head X data and say 20. Yeah, so there's the first 20. So the idea is it's increasing very fast at first. Well, pretty fast, right? Increases by about 300 in the first 5. In the next 5, about half that. The next 5. About half that again, so it's still kind of increasing fast, but now you can see it's sort of leveling off. So I do expect this to look like something like curved like this. So let's, the file read in, it must be read in. So I'm going to put things where I want them. So let's have X equal to, sorry, I forgot again. So the first column's V, TU, VW. Yeah, okay. So it should have been the other way around. So X equals EXP data. I want the first one, right? I think so. Let's just do it like this so we don't have to. Yeah, okay, this is what it should look like here, right? So, get this. All right, so increasing and then decaying like this. So one kind of model for this would be something like, let's even look and see. It looks like it's staying under 1400 or maybe a little more. And it looks like it starts down here at 0. It's about, it's never quite at 0, is it? But it looks like it starts somewhere, I don't know, like, what does that look like to you? 300 or something. So you could have something like this. So this could be like 4, sorry. So let's put this in. Let's actually try to plot this as we do it. So one thing you could do is use the curve command, and use it with try it and just see. This is a quick way to try it without using tools and things like that. Even if you use Lois or something, it won't tell you the function. So you have to do a little exploring and try to find something that's close before you call the model. It's not like with linear where you can just, the linear LM, you can pretty much, you don't give it a starting point, right? You just call it with the data and it does the rest. With this, if you don't give it a close starting point, you could be doomed. Okay, so let's try something like, here you can just type in pretty much any acceptable R function. So I'm going to type 14. I thought about this before, so you would think about this. I'll pause for a second. Say minus 0.05 times x, and then type add equals true. Otherwise, it will delete the previous plot that it made for you. But if you do this, it will plot it on the same curve. Okay, why did I come up with this? Well, this is a standard one, kind of. When x is 0, you can see you're at 300. When x is big, you're at 1400. So that looks like what's happening, right? And how did I come up with the minus 0.05? I actually did this by hand a little, just a couple quick calculations. If you put in 80 in there, and you get, and then you do that, what do you get? Say I put in 80, or say 100 even. So then I get minus x. I get e to the minus x. I'm sorry, I get e to the minus 1. So I get 1100 over e. So that's about, I don't know, that's too big actually, right? That's too big. But I went further. I went up to 100. I don't know, I get minus, what's 80 times this? Minus 1 point, what's 80 times 1 over 20? Oh, it's minus 4, yeah, duh. No, wait a minute. 80 divided by 20, yeah, is minus 4, right? 80 times 0.05 is minus 4. Right, so I have e to the 4th. Right, this looks better. E to the 4th. So this is going to be, I don't know, 20, 1 over 20, right? So this is this divided by 20, so this is like 55. So this puts me at about 1345 or something at 80. So it's off a little, but anyway, I played with these numbers and to come up with this, but then you can just type it in and see what it looks like. You see, it doesn't look that good. So it looks off a little. So you could adjust it and bring this up a little, I think. If I bring this up to maybe 4. Okay, well, they don't look too good, but you know what? It doesn't look too bad. And the idea is you want a ballpark thing that you can give to R, okay? So maybe I'm forgetting. Maybe, oh, we could adjust the 0.05 too and maybe make it come up a little faster. So say 0.4. Sorry. See, that one looks better, so. No. I don't know. Mystery. Okay. Anyway, we want a ballpark thing. So let's see if we can now run the NLS command. So remember, NLS is nonlinear least squares. N stands for nonlinear, L stands for least, and S for squares. So let me try this. So I'll type mod, or let's try NL mod equals NLS. And now I'm going to put in, and since I have things written in Y and X, I'll just put Y response to X. Okay, but I don't want just X. I now put in a formula, and I use just, you can use whatever variable names you want, but I'll pick something small so that it's more readable. EXP. Now, what do we really want? We want A plus V times EXP C times, I don't know why I'm putting all these spaces in here. Let's come back here. Okay, there we go. A plus B, e to the CX. This is what I'm trying for anyway. And you got to tell it a few more things. So you tell it just one more thing's required is to give it the starting values. Okay, remember the Gauss-Newton method. If you read that, saw the videos, you know that this is important. So you have to tell it where to start. So let's have it go A. I think maybe let's just try something not 1400. Maybe we'll try this. We'll just pick some things and say B equals, we just want to be in the ballpark. Say, I don't know, 1150, and C equals minus 0.05, say. All right, there's my list. That's my command. I return. Wow, that returned fast. I didn't expect that to happen. It must have, I'm not even sure. Okay, yeah, looks right. So let's try summary and L. Maybe because I did it before and it saved it or something. Even if I gave it different start values, it might have said this is the same X and Y, and it did it before, but it took fast. Okay, look, well, no, it did. It took the start values we gave it. It did a different thing this time. Okay, look, what comes out of this? So remember, this is the Gauss-Newton method, and it did several steps here. Look how significant everyone is. And by the way, it's 1401, very close, and we get about 1,175, which is around 1,200 and 1150. So very good. And then instead of minus, what do we try? 0.05? That was the problem, I guess. The real thing is minus 0.095. So it's a bit higher. Yeah. Okay. So what does it tell you? It tells you, it gives you these estimates here for these. It tells you a standard error on each. And this is using the large sample theory. Okay, that these data are approximately normal, at least enough. And the t-value, t-statistics for doing tests, this is all in the lecture. I think not the previous one, but the one before that. And also in the book in 13.4. It gives you residual standard error. You notice it doesn't give you R squared. Reason is, in nonlinear regression, R squared is much more unpredictable and doesn't really have the same meaning. Okay, it doesn't range between -1 and 1, and it's generally not used in these things. So yeah, and then that's just about how the algorithm runs. So that's important too. You might remember you're allowed to make the assumption that it's normal if you have it converging in a few iterations. 7 is, I'd say, a few, or moderate, but it's not many. I mean, you can see these in much bigger numbers. You start seeing 50 or something, then you have a problem for sure. 7's okay. But let's see. I mean, they can be smaller, but it's not bad. All right, so what should we do now? So we see, so let's plot. So the way I do this is there's all these tools to do it, but one thing you can do too is just plot the curve with the data they give you. I could use the coefficient command. So we could do that. So let's put in, but you know, this is so easy. I'm just gonna put in minus 0.095. Since it's all right here, and 1175 and 1401, right? And let's make it, can we change the color? Call equals, you can look up the hexadecimal colors and make all kinds of pretty colors, right? So we can just try that. Okay, let's see what we got. It looks okay, right? Yes, this one looks really nice. So it was that minus 0.095. It had to jump up more. I'm not really sure what was going on over here, but you know, we don't. Okay, look how pretty that is. So there's your model. There's your model, okay? Dr. Fauci would be proud of you. Okay, so you have a No, actually, this data was very fabricated, so it makes sense. It has a nice fit. All right, so this is it. This is all the commands for everything, for what you need to do to run the models on the problems on the test, and for really just to start playing with this. So I think the only other thing we should do maybe is I'll do one more example where it's not as, it's really just some example from the problem sets from the book, and I didn't check to see that there were any nonlinear. I don't think there are any nonlinear fits for it. So it's just something I just wanted to throw something in there and say, how would you just approach it, data cold like this and do this? And the answer is you probably wouldn't, but still, it could give you a feeling just maybe where it doesn't work so nice. So, so is that okay? So let's, so I owe you two R examples, one on bootstrapping and one on nonlinear least squares modeling, and I will throw those up on your course page. Yeah? Okay, so let's go to one other one here, I think. Should we? Yeah, okay. I don't remember. See, I'm a little nervous that if it doesn't work, it doesn't work, and I can always I guess delete the end of this. So last lecture, just the last one. So okay. What do we have? So I wanted to do the patient satisfaction. So PS equals read.table patient. Yep. Okay, and you remember this one? We had satisfaction versus, say, all of these, and they were negatively correlated, right? The older people are less satisfied. So let's do satisfaction versus age and try to do a nonlinear fit for it. So I'm going to do the same thing again. I'm just going to call it X and Y. You don't have to do that. Let's see. So let me get it right this time. X equals PS age. Y equals PS status. Okay, and let's plot X, Y, the response. Okay, see, not as pretty. I mean, there's more variation, of course, and but it does look like, if anything, we could have a bit of a decaying simple exponential model with a positive A parameter, positive intercept here, and a negative exponential coefficient, you know. So like we could guess something like maybe, if it's really exponential, it's going to shoot up. So we could guess something like 300 or 200 or 400, and then e to the minus, and probably, you know, you don't want to make it, well, who knows? Okay, so e to, you know, these numbers are getting really big. So I'm thinking e to the minus 0.0 something. Okay, so let's plot a curve. So this is probably like your starting point. But there are tools to do this too. You notice, however, if you use the lowest, it does a nice plot for you, but it won't give you a function to use, okay? So there's other techniques, there's other tools. We're just starting. So so let's say we try it, something like that, just to get a feel for it. So curve, how did that work again? Curve, let's try 300. I'm literally just making this up. So we're just trying this EXP and say minus 0.02. I'm making it up, I promise you. Okay, so this is this, and I'm going to say add equals true, and that's it, right? I don't see anything here. I missed it. So what's happening? It's too high, or it's not decaying fast enough. So I could do either of these. Let's try to boost this and make this maybe a little smaller too. There we go. You see, it was above the whole curve, so it wasn't being shown. All right, well, this looks pretty good, actually. I probably want to come up a little. Wow, it's going to get really steep here then, I guess. Let's make it Right, right, right. You notice you can play with axes too and then see more of it. Okay, but just to get going, we just want a starting point. I mean, I could probably call NLS right now, right, with a starting point, but let's try to maybe give it something a little more to. So I want to be somewhere between maybe 2 and 5. So try 4 and maybe up slightly. Yeah, that looks good. That looks really good, I think, right? Okay, so, and you know, this isn't a function. This is just random data from that set of outpatients. So, you know, this may not be the best fit. You need to do lack of fit testing. There's all kinds of testing to be done still. So let's try to fit it, right? Let me call up the other NLS command that was here. There it is, right? So this time I just have 2, and I got to tell it where to start. So I'm going to give my best thing in here. So minus 0.04. Give it the best chance. It still might not be that good because the data's a little crazy here. So, and 275. Okay, and the model has to change, right? This is B now, and this is A. And there we go. Okay, let's call it, wow. I don't even understand how it did it that way. Okay, my computer doesn't do anything else fast. Okay, so yeah, okay, so let's summary. Not bad, right? Wow, not too bad. All right, so let's try to yeah, wow, it looks pretty good. They're both significant, all this stuff. So 5 iterations, even better. So it appears to fit, to have some significance here. Let us now plot the fitted curve. There's got to be a way to do this with the NL mod too, just putting it into a plot. But if I just do a plot, my screen goes blank. So I don't think that's the right command, and I don't want to bother with it. So let's just fit it in here again. So I'll put a color in here. So call equals green maybe, and change, right? So again, we could look this up. It's easy enough just to, I could use coefficients, right? And this one should be much lower. That was interesting to me. All right, there we go. I don't know if you can see the green with me. Wow, look at that. Look at that. It's nice, huh? Okay. All right, guys. Well, thanks for watching all these. And that will be it. I'll be in touch in the email. Take care. Stay safe. Adios.